All right, good morning, everybody. It is 10 o'clock, so let's get started. My name is Christine Queno. I work at the University of KwaZulu-Natal in the School of Agricultural, Earth and Environmental Sciences with the Friends of UKZN Agriculture Association. Some of you may recognize me from the DLB workshop that we held in October 2020. So it's really nice to see many of you again. So welcome to this webinar. It's the first of a series. It's on plant variety design for emerging markets in Africa. And I'll just give you some housekeeping before we kick off. So this meeting is being recorded, you will have seen. We would ask that you keep your video off and your sound muted. It is a meeting setup as opposed to a webinar. It also is probably better if you click on the view icon at the top right of your screen. If you switch to speaker view, then you'll be able to just see the person who is speaking. And we would ask that you also make use of the chat function when you would like to ask questions. Just bear in mind, if you're posing questions during the meeting that will only be addressed in the discussion session, that we would just ask that you direct the question to the speaker that you would like to answer the question at the end. And then in our discussion session at the end, if you would like to ask a question live, there is a raising hand function. Many of you will be familiar with Zoom by now, so you'll know where to find it. But if you don't, it's at the bottom right of your screen. And that's if you want to pose a question virtually. We will be keeping to time though. So if there isn't time to address your question, it's useful to have it in the chat function so that speakers can see it and possibly address it right there when you pose it. Otherwise, we can discuss it at the end of the meeting. And then we will communicate with you after the meeting is done as to where you can access presentations or recordings of the meeting. And there will also be a poll at the end. So please do make sure that you answer the questions that we pose to you. It will be very useful going forward. And then I will not take up any more of everyone's time. I'm going to hand over to Professor Hussein Shimalis, who is here at the African Centre of Crop Improvement at the University of KwaZulu-Natal, and he's going to just give us some opening remarks, and then we will take it from there. I will just pop my head in between each speaker so that you see me and that we just give you a little introduction to who will be speaking. So over to you, Prof. Shimalis.
Thank you very much, Christine. Good morning, everyone. I hope you hear me properly. Otherwise, just alert me that you can't hear me properly. Thank you very much, and greetings for everyone from Pietermaritzburg, a city of choice, that we will be hosting this event online. Essentially, it was supposed to be face-to-face workshop to learn more on the issues of making cases to invest in demand-led plant breeding. Unfortunately, because of the our current circumstance related to COVID, we had to schedule a Zoom webinar. So again, welcome, and my name is Shimalis. I hope most of you know me. I am academics at the University of KwaZulu-Natal. I'm a professor here in plant breeding, and I'm a core member of the demand-led breeding, which has scheduled this event for our discussion today. So welcome again to this important event, which is making the case for investing in demand-led plant breeding. We are pleased to have you for this online event, which is intended for agriculture research and development and plant breeding community in South Africa, in Southern Africa, and also at large in Africa. So the event is just a dialogue to strengthen plant breeding and to make the case for investing in demand-led breeding in Southern Africa. So we hope that you will gain a valuable lesson or some evidence to make the cases and to support our research and development initiatives from this workshop. I think before we start the main activity, please allow me to thank the following individuals on behalf of the Demand-Led Working Group. Demand-Led Working Group is an international initiative. It's between Africa, Australia, and Switzerland partners from these countries. So I should really thank our keynote speakers. Thank you very much for generously accepting our invite. It's not easy for you, we know. You have devoted your valuable time to share your wisdom and to offer guidance based on your knowledge, long-term experience, and influence in the region. We really are proud of you to have and share your experience with the young plant breeders and research and development stakeholders. And to you all, to the esteemed participants for willingly attending this event, and your presence is really recognized and appreciated. We also hope that you will make active participation. Thank you very much for joining us. And Dr. Sally Frost, the Public Relation Manager at UKZN's College of Agriculture and uh, College of Agriculture, Engineering and Sciences, and her team for organizing this important event for us. So what we have done is we have lined up keynote speeches followed by extensive discussion based on the agenda items that you have received from Sally and her team. So I think these are my opening remarks, and I wish everyone a fruitful discussion and deliberation. And thank you again for joining us for this important webinar. So Christine, take it from here.
Thank you, Prof. I'm just going to hand over to Dr. Nasser Yao. He is the demand-led breeding Pan-Africa coordinator, and he is with Alliance Biodiversity at ANCIET based in Kenya. So he is going to just give us a little bit of an overview on the DLB or demand-led breeding project. So over to you.
Nasser, hello Nasser.
I think you'll just have to unmute yourself, Dr. Yao.
Okay. Hello?
Yes, go ahead, Nasser.
Okay. But I can see the screen. Okay, let me. Okay, good morning. Thanks for really inviting me, and thanks Mary also for organizing. Is it okay? Hello?
Yes,
Yes.
Nasser.
Okay.
Okay.
Yeah. And thanks Mary and the team for organizing this dialogue, because it's one of the key components of what we are doing under the demand-led plant breeding. And my presentation was just to give some kind of overview of all the DLB approach, because of course we are focusing on how to make a business case to invest in demand-led breeding, but we deem that it's also important for us to share some highlights on what the project is, how was it initiated, and then what are really the current link with the current project that we are having here. Are we on the outline?
Yes, we are.
Okay. Yeah. Then that's what I'm going to do broadly, to give you some kind of definition about the demand-led plant breeding, the main achievements, the main pillar, and also go to some concluding remarks where we can really make a link of what the current, the old project is sitting in the current activity that we are having. Some time back, the genesis of the reason why we decided to establish this project is we're asking some key questions. That's why the adoption rate of modern variety in Africa is low compared to Asia and also Latin America. And again, how do you want to consider ourselves when we say that I'm doing good in breeding? What could be really our criteria to say that we are doing good? Because usually it's okay, you are releasing variety. Is that enough? And again, how we are going to measure success when we say that breeding is doing good? Because when you want to communicate in this kind of world where communication is key, you cannot only say things without any fact. What are really the reasons or the criteria, or let's say the the key performance indicator that you can use to say that you are doing well. And then finally, how breeding can be effective and efficient. Effective, it can happen. Okay, effective means that if you plan something, it will happen. But efficient is how soon, how long. Because in the new approach that is market oriented, then if you don't do things quickly, faster, and even accurately, you might not be able to get it. And then after this question, then we have decided. I'm not seeing.
You are fine, Nasser.
Yeah, but I can't see the audible. I don't see my thing on the presentation mode. Let me. Is it okay? Yeah, and then we just decide to create this project of to put up the demand-led breeding project, which is an alliance formed by the Crawford Foundation, the Syngenta Foundation, and the Australian Center for International Agricultural Development. And this alliance also, this food security alliance was also formed with some universities in Australia and also in Africa, as well as some international organizations that you can see them below there. But okay, those one who are not that, there is those one include the West African Center for Crop Improvement, the University of Nairobi, the NARO is which is the National Research Center in Uganda, Makerere University, the Alliance Biodiversity Chat, and also uh, the Ethiopian Institute of Agricultural Research. I did it on purpose to let the African Center for Crop Improvement at the last because they have our current host. Then this Food Security Alliance, what was really the aim? The aim is really to turn farm breeding into a kind of business. That's my response to market demand. And then basically what we want to do, we want to allow breeders to develop high-performing variety that meet customer demand and also, let's say, the market concept. And what we want to do this one is to consult all sorts of actors, including also the farmers, but also the stakeholders and also the actor of the value chain. Finally, the demand-led plant breeding, if you have not got the gist of what we are telling you or what you saying, of what I've tried to go through all those few wording, is just to have in mind that is an approach to develop ideal performing variety that meet customer requirements and also market demand. Now, I just want to make a kind of few one statement about what is really DLB compared to participatory plant breeding, because in most cases people used to say they are the same and they are similar. Yeah, I can understand why it's perceived like that because there are some kind of good similarity, like setting the goal, the objective, generating cross. Those one are normal breeding stuff. But what a DLB make it different compared to participatory plant breeding? DLB I brought us up. Many DLB will targeting agro-zones because zone when PPB will be focused on some kind of local. The market is wider, let's say wider. We targeting in DLB, we are targeting wider market, regional, international. And also, one of the big difference is the type of actors that we are dealing with at the beginning. In the PPB, it's most the breeders and the farmers, where in this one is many stakeholders, all the actors of the value chain, and also all the actors of the value chain. And then this one makes it a bit different, and note this one also come with some other type of mechanism that goes with DLB. From the beginning, since its inception in 2014, yeah, we have gone a bit a long way, and then we have developed some kind of good stuff. The DLB book, for example, that is there is available. We do have some few copies here for those people who are in Nairobi, or for those one who will be participating to the African Plant Breeder Association. Yeah, we can still have some copies for you. Otherwise, it's online. And on the DLB website, yeah, I'm going to give the link later, and you can have also get it printed. In the meantime, for us to do those kind of things, all those concepts that is on this book has been put up in kind of presentation and then on kind of courses, and we have been training over 40 people which constitute, by the way, what we call our community of practice, meaning our GLB community of practice, which are some people we see also later who are kind of common interest in doing this teaching. And again, what we do, because of we want the GLB to be embedded even from the beginning, yeah, GLB has been included into the curriculum of partners universities, the West African Center for Crop Treatment, the ACCI, the University of Nairobi, the Makerere University, and the Makerere University. We have also developed some product profile and some also practitioner guide. The product profile is really how we can add a kind of summary of the whole your variety so that we can teach it easily. And then the practitioner guide is how to develop this product profile using this template and also the kind of underlying information that we should do. Yeah, DLB also has been institutionalized in so many universities that we start and also in how do you call it, in Ethiopia. What we are trying also to do is to deploy practically the DLB in private and public and private institutions through the PABRA network and corridor. And the kind of dialogue that we are having today is part of what we call the practical deployment of the DLB. Even though in this case, our main aim here is how really you can make a case, how really you can advocate for investing in the DLB practice. Yeah, the DLB community of practice is form of 400 people. What I would just want to show here is that those one are various people who are plant breeders and also over, let's say, crop related people with crop related interest, and then coming from NAS, universities, and also, let's say, government institutions. And here the crop is a wide range of crop, meaning no matter what you are doing, no matter which crop are you working, no matter where you are from, you can be part of the DLB community of practice. If you are interested, that's the website. You can just also drop me an email and then you'll be part of the DLB community of practice that has been organized into some kind of thematic group that you can see. That's there. And then I just want at this step to have some kind of concluding remark that we got from all the implementation of what will be having that we got when we were implementing DLB those last 4 to 5 years. Yes, that DLB should be seen like, or even breeding should be seen like a business. That will be can respond to market demand. And also, within that is really there is a necessary paradigm shift to think from participant plant breeding to DLB. Meaning what we just want to have is to have the inclusivity of all the key actors and also the stakeholders of the value chain. Because this one will be make it broader and then you make people being owned on the product that we'll be having, because one of the main aims is how are we going to make adoption much more higher. And again, we can see that breeding can make impact, and then at the economic, social, and environmental, and also individual household and also community level. And I'm quite sure that we are from those our eminent guest speakers that will be let's say presenting after my talk, you are going to see what to me, what our economic, social, and environmental impact the plant breeding is really having. Then those ones can just constitute some benefits that can justify why we should invest in plant breeding or in demand-led plant breeding. Yeah. Is in this making this case for investment, one of the things that we really want to do and push for it is to see breeding as a cost, to change the perception as for breeding as a cost to breeding as investment that can give return. This one is key. It's not only just for employment, but is not also for cost, but is an investment which can give transfer of benefits. Because this benefit can serve many people, including farmers, consumers, and other actors of the value chain. And as I was saying, also there is all those economic, social, and environmental benefits that we are having. And again, to make the case for investment, it's also good to know how to advertise your product, how to pitch for your product, mainly to different audiences. That is key. And that's one of the reasons why today you can see that from the panel we invite so many 4 speakers with various competencies, because this one also is key in terms of communication. And then making the business for investing in plant varieties design is one of the 7 key pillars of the whole DLB project. And then it's a kind of sunrise. It's here even in this, let's say, slide is sunrise, but also there are so many other, let's say, pillars that are equally important for the DLB project. This includes visioning and foresight for setting breeding goals. It's just to have a kind of, since plant breeding is a long process, to have a kind of, okay, what will be the market, the agricultural landscape. You can see that we have the presentation. One will be the whole agricultural landscape in Africa. Those are the things that is important to see. Understand player needs, new varieties, design a product profile, monitoring and evaluation. Those one are the things that are not really practical, common in the normal plant breeding. And the variety development and sales plan, and also the invest on returnment. Okay, it's a 5-minute presentation. I try to summarize and to give you a gist of what is DLB and what are we expecting also from the current presentation that are going to go on. Then for it, I would like to thank you here and really thank you for your attention.
Thanks so much, Nasser. I hope that has given everybody a good overview of what we are talking about. So our next speaker, you will have received the bios, but I'll just give you a little introduction, is Professor Richard Sikora. He is an emeritus professor from the University of Bonn in Germany and a fellow of the Stellenbosch Institute for Advanced Study here in South Africa. And he has worked in several countries and has more than 5 decades of experience in agricultural sciences and has collaborated with many people across different countries and continents on several issues, and has received a lot of international awards as well. So with more than 300 peer-reviewed publications and books, we're going to hear a little bit more about his experience that was covered in the open access book that was published last year called Transforming Agriculture in Southern Africa. So I'm going to hand over to you, Prof. Sikora.
Okay, can you hear me?
Yes, Richard. Yes.
Clearly or?
Very clearly.
Okay. I need to put on my talk. Okay. So I want to thank Hussein for inviting me to take part in your meeting. It's a pleasure for me to join so many eminent breeders from Southern Africa, because you are a definite strong part of the building blocks of good producing more food in that particular area of the world. I'm surprised that I was invited and that I'm a pathologist and I like sick plants. I don't really like healthy plants. So you people are working against the pathologist in one way or the other. I'm also very impressed with the number of people taking part in this meeting. There's 93 people on the list right now. And every one of you are basically new colleagues for me because I don't know any of you. So it'll be a challenge to give a talk to make you believe what I say, I guess I would say. Now, the book that I'm going to talk about was targeting basically policymakers and small farm improvement for food production. There were 67 authors in this book, 37 chapters, and we asked each of the authors, who basically live in their own tunnel, to outline the best techniques that are available on the shelf right now for a small farmer, and a vision of what is needed to get decision makers to fund or to support that particular technology. So what the book then does in the end is you have 37 people, all of them with their own little tunnel vision, telling the policymakers what he should do. And makes life difficult for a policymakers, as you can imagine. Now, in the introduction to the book that we have, Per Pinstrup Anderson, who was the former DG of IFPRI, asked the question, why is it that African policymakers are still confronted with huge challenges, food production, for example, and why are so many African children still malnourished and natural resources degraded? And he said, maybe the lack of evidence is not the constraint. Maybe the solutions are not reaching the decision makers, or are irrelevant to the situation within which the decisions are made. Now, a policymaker is influenced by all types of interest groups. He's influenced by the people at this meeting, for example, the breeders, the pathologists, the NGOs, et cetera, et cetera. So he's under an enormous amount of pressure from different groups to make good decisions. And that may not be his priority. Each one of these pressure groups has his own priority, of course, and the policymaker has a different policy. He wants food. He wants better production. So it's a lot, producing more food in Africa is a lot about pragmatism, good farming practices, and it's not about tunnel vision. It's about good farming practices. And that's what we learned when we developed this international forum at STIAS. The International Forum of STIAS was developed, how do I move this forward now? How do I go forward here? It's not up over here maybe.
Press page down maybe.
Okay, the STIAS Long-Term Research Forum was developed in 2014 by myself and ran until this year, and it is still running. In this forum, I was allowed to have 5 senior fellows from around the world. Some of these you might even recognize. Eugene Terry, who was basically responsible for policy and a little bit of breeding. Paul Fleck on the right, who was a soil fertility man and climate change expert. Myself, the pathologist and ecosystem ecology. We had another man whose name was Janusz Bogardi, a world expert for water, and Lucas Kekale from Botswana, who is working on policy and agriculture production in Southern Africa, and Joyce Chicha, who was working with gender and capacity building. We organized a roundtable discussion. The people you see in this particular picture were the people who took part in that roundtable. And the idea was, the vision of the roundtable was to ensure a full and nutritious food basket for all in Africa, in Southern Africa. The title of the long-term research forum was very complex. It was to study the impact of sustainable intensification of agriculture in Southern Africa on food security, the environment, and human well-being in the rural-urban continuum. When we developed the project and we developed this title, we all looked at each other and said, are we going to be able to do this? Because this covers about everything one can think of in Africa. I don't have a lighter here. So the challenge is basically, can Africa feed itself? This was the challenge we had when we developed the book and the ID product forum. And in 2050, the population of Africa will be 2.5 times larger. You know that. We cannot produce enough food at the present time to feed everyone properly. And this is a problem around the world, not just in Africa. We have small increases on the present farm. Small increases in production on the present small farms will not prevent expansion of the agricultural uncultivated areas. They will have to expand into natural areas. This will lead to a loss in biodiversity and increase in greenhouse gas. I think you know all of these things. And yields are still low. And as you said in the first talk, Nasser said that only 30% of the varieties you people are producing are being accepted on the market. This is not enough, of course. Maize yield in Africa is only 20% of potential yield, and of potential yield where you have good management. The USA and EU is at 80% of potential yield. We have extremely strong management inputs. The imports will not cover the need for grain, and self-sufficiency in 2050 and beyond on existing land requires an increase to this 80% of potential yield, or at least a move towards that potential. The question is, can we meet that challenge? And I say, like Barack Obama once said, oh, yes, they can, or yes, we can. So this is the book that we produced after the first 5 years. The forum met every year for 2 months with 5 people, plus 10 to 20 experts, invited experts from around Southern Africa to discuss the building blocks of good agricultural practices. We wanted to talk about agricultural production and not about individual constraints, individual technologies. The book, however, has these chapters that are very strongly orientated towards specific technologies: breeding, plant pathology, post-harvest, toxins, et cetera, et cetera. We wanted to get this broad vision of what is agriculture. And this is very difficult for the fellows, because none of us were agriculturalists in a sense. I'm a pathologist. Eugene Terry was a politician, basically a political person. Paul is interested only in fertilizer. None of us have a farm, and none of us know what good farming practices really are, although they're in books. And can you hear me? Can you hear me?
Yes,
Richard.
yes.
Yes, we can hear.
Okay, good. Agriculture production is a very complex. I have to get rid of this thing up here. Okay, I got to go back. Something's going wrong here. I lost my talk. I'm sorry, people, but I've lost my presentation someplace.
It's fine. I think you can upload it.
There it is. I'm sorry about that. So agricultural production systems and food chains are highly complex. It's not just about varieties. It's about everything you see in this map. And everything in this map is covered in that book. It's about the constraints, the drivers, and of transition. How do we change the present situation? So what we did is we decided to bring all these experts in and talk about the building blocks of good agricultural practices. And we talked about the following, we considered the following the most important. Market access, population, of course, infrastructure, soil degradation is a major problem. We talked about extension and IT, improving soil fertility without fertilizer, climate change, pests and diseases, post-harvest, strengthen the agronomy, water management. I don't have anything in here on breeding right now, but breeding, of course, is in here, strengthen the agronomy. But the major target of the whole group was political willpower. How do we get to the politicians, and what is needed by the politicians to make a decision? So we now have 37 chapters, and every one of the writers told those policymakers what he needs to do. And the question is, does a policymaker understand all 37 stress points? And that's the problem I think the policymakers have. We tell them breeding is important. We tell them pests and diseases are important. We tell them climate change is important, but he still has to make a decision with not necessarily a lot of money, and he has to make a right decision. And whoever is influencing him at a specific part of time also can skew the decision away from the best decision. So Southern Africa, it's two of the major things we talked about, is that there's a hot spot of climate change. And this is going to get worse. We see it already in California and southern western United States, extremely hot weather, abnormal as can be. And it's the same thing happening in Africa. We're going to have increased hunger. The climate's going to get hotter. You know that as breeders, you're breeding for resistance to heat and to stress. We're going to have reduced water availability. We need plants that will grow better with less water. We'll have accelerated soil degradation. We have extreme levels of soil degradation. We have soils in Africa, Southern Africa, that do not react to fertilizer. We have a significant drop in organic matter, a significant infrastructure problem. We're going to have loss of biodiversity, and we're going to have migration to urban areas off of the farms. At the same time, we have another hot spot. The hot spot is the big giveaway. The big giveaway is basically the 40% of everything we produce that's given to rats, mice, aflatoxins, nematodes, fungi, and insects. 40% of everything, up to 40% of everything the farmer produces is basically given away to these organisms, and they feed on it. This is food that's not going to the people in the country. This is potential yield of maize. This was in 2004, so it's an older slide, but this was the potential yield of maize in these parts of the world. This is what you get if you have no management. You have poor varieties, you have no pesticides, you have no fertilizer, your water management's poor, you have no rotation. This is the yield. The red is the yield we're getting right now, and this is the yield we're getting in many small farms in Africa. We're getting it in northern, western, eastern Africa. We're getting it in South America, in Mexico. But in those countries where we can put production inputs in, this means management across the board, the yield changes drastically. In the Netherlands, we're almost at 80% of maximum. There's very little more room for expansion of production in these countries. In the United States, there's a little bit more. In Africa, where you see that green line, that's what you would get if we had the management we need. This may be what we have in South Africa and some of the bigger farms. But the red circle is what you get with no management or little management. And that red is where we're at in Southern Africa. We need to change. We need to be moving towards higher levels of productivity, towards the optimum potential of our crops. This is only maize. So climate change is going to affect Southern Africa more than many other parts of the world. Brazil will be affected. You can see the boxes of sugarcane, rice, wheat is going down. Southern Africa is going to be heavily affected by climate change. Other areas of the world, China is not as much affected. Southeast Asia is partially affected. South Asia a little bit more. So we have to expect a major impact of climate change, and this was stressed by all the people working on this forum. Oops, wrong button. So I'm going to conclude now with Hussein gave me 10 minutes. I don't know if I've gone 10 minutes already, but we have to reduce pest and disease losses through IPM and improve agronomy. We have to improve agronomy, not just breed resistant varieties. We have to have good resistant varieties that react to good agronomy. We have to target soil fertility and even fertilizer subsidies in some cases. We can increase yields drastically with a minimal amount of increase in fertilizer, but also by increasing soil fertility through the introduction of organic matter by changing farming systems. We have to take advantage of an increased farm size. There are increases in the size of the farms across Africa. It's slow, but as farm size increases and we get certain subsidies maybe from the politicians, we should be able to increase yield and improve the impact of the new varieties that you people are releasing. We have to have targeted breeding for pests and diseases, climate change stress, that means water and heat. And it's very important that when you breed for water and heat, you're talking basically by water about the root system. And if you do not simultaneously breed for pests and diseases in the soil, which is very difficult, your water stress varieties are not going to work because you have pests and diseases in every soil ecosystem and they affect the root growth of those crops. So we have to improve crop diversification with another conclusion. We have to improve urban and rural markets, both small and large, and the infrastructure for the food and value chain. We have to promote funding for entrepreneurship, for economic development. We have to support small-scale renewable energy and mechanization, and we have to build human capacity and gender support. Now, if I went to a policymaker with all of those points, he would probably shake his head and would not know where to start. And this is what happens to our policymakers. So I made a couple points here. These are my feelings. These are not necessarily in the book. But I think the breeding targets to improve crop health and yield for small farmers has to include, of course, tolerance to heat and water. Resistance, however, to soil-borne pests and diseases is an absolute necessity, because if you have soil-borne pests and diseases like fungi and nematodes and insects, you're going to not be able to counteract the water stress system because the root system will remain flat. It will not go down. We have to improve the acceptance of biochemical seed treatments. The majority of seeds in Africa, especially across the small farmers, are not seed treated. Every seed in the United States, every seed in Germany, no matter what crop, is seed treated with a fungicide, often with an insecticide and even a nematicide. This has to improve. Cultivars that yield at low fertility to moderate fertility should not be just taken off the desktop. When we lose the chemical control in the near future, chemicals are leaving the market quickly. We have to have varieties that will yield even at lower fertility as we increase the fertility in the soil. Increasing soil fertility in Africa is a long-term thing. It's not something that's going to happen tomorrow. We have to have resistance to the mycotoxins and aflatoxins. The children in certain parts of Africa are 20% shorter than in other parts of the world because of aflatoxins in the grain, especially in peanut and in maize. One of the authors stressed, and I think it was stressed also by Nasser in the first talk, we have to get the seed distributed. If the farmers don't get the seed, if they don't use the seed, and if the seed is not properly treated, it will not grow properly and they will not use it. So can we get 80% potential yield? I think we cannot do that only through breeding. We have to do it through a management system that includes the total good farming practices. And can policymakers balance funding to promote the best bet building block combinations? That is a question that's open to discussion and to debate. The policymakers must avoid tunnel vision. One technology does not solve all problems, and it will not solve the food security problem. We need to work in scientific equilibrium with the other disciplines that we're surrounded by in our universities and research stations. It should be the name of the game. We have to work in a group and multidisciplinary approach to increasing small farm production. Food security will be determined by smart policymakers. Now, solving complexity and getting to the policymakers is something that I'm working on now at STIAS. We have a new project. We're solving complexity through policymaker decisions that decides who gets funded and makes progress. So the future research project at STIAS that starts in March, April, is a project called Developing a Complexity Science Capable of Solving Practical, Important, and Urgent Problems. This new project is looking at that map above you, looking at all the chapters in our book, and trying to put them together in a dashboard type decision-making system that will help policymakers make the right decision, the economically best decision, and the decision that's best for the country and its people. And with that, I want to thank you, and forget it's not about us, it's about our children's children. Thank you.
Thanks so much, Prof. Sakura. That was such an interesting presentation. I'm sure that we'll have some questions coming up about that. You will see we are a little bit behind time, but don't worry about that. We will make it up as we go. Our next presentation comes from Dr. Shadrach Mupuli, who is the President and CEO of the Agricultural Research Council in South Africa, and also has experience working with our departments of agriculture and in genetic resources and with agricultural production. He's also represented South Africa at the UN FAO and at a lot of international meetings. Now, the Agricultural Research Council has a strong mandate for research and development and technology transfer in South Africa. So we are going to hear a bit more about the research and development going on in South Africa. So I'll hand over to you.
Thank you, Professor Shimelis, and thank you to the hosts for inviting us as the Agricultural Research Council to speak at this particular platform. I think after two excellent presentations, especially the last one that's representing 67 participants or experts, I'm at a loss as to what more to say. But be that as it may, I think it's important that perhaps we share a few notes with you as the Agricultural Research Council to put some of the key things in context within the milieu of what you could call the South African context. Yes, I am in agreement that the population will increase by 2050 And I am in agreement with the comments by the previous speaker that in order for us to be able to meet the food demands, production yields as well as the efficiency, which means productivity, must also increase. And we need to find a better way around which to achieve that. Now, there are a variety of things that we need to also understand to get there, including the fact that we're currently within the pandemic, which is in a sense also having its other impacts around our food systems in general. Therefore, we need to find different ways in which we are going to be able to achieve these particular issues. The challenge for South Africa, and indeed for the rest of Africa, to feed itself has now been also indicated by the previous speaker, and become a major food supplier for the world's is compounded by the need to produce, not only in terms of yield and efficiency, but to produce healthier, safer, and more nutritious food on less land, using less water and chemicals, and producing less waste and less greenhouse gases. The demands also explain why Africa has also, as a collective, resolved to pull together what we call the science agenda for African agriculture, essentially saying that by 2030, Africa is food secure, a global scientific player, and the world's best bread basket. Now, it may represent a delayed but urgent and realizable opportunity for Africa to fulfill this particular destiny in a way that articulates the science, technology, extension, and innovations, and policy and social learnings that we as Africans need to apply in order to meet our agricultural and development goals. In a sense, we've pulled together as a way in which we are trying to implement the Comprehensive African Agriculture Development Program, which is a broader framework for transforming agriculture in Africa. Science and technology is an essential part of this particular strategy, and in a sense instigates an agriculture-led social and economic transformation. I think that's the message that perhaps we need to also need to get our policymakers to understand. Of course, we know that most of the African food systems are largely dependent on smallholder farmers and small enterprises for further processing and marketing. You have heard from the previous speakers that perhaps we need to increase the farm sizes. Accordingly, smallholder family farms are an essential and critical element for ensuring food and nutrition security that's what currently exists, including for improved livelihoods in many rural and marginalized communities. Large commercial farms, as we commonly know of, even some of the best farms in South Africa, they also experience some of the similar challenges of yield and productivity. However, such production systems are often challenged by many other factors, and some of those factors have been outlined by the previous speakers, such as lack of resources for effective improvement of natural resources in terms of poor soils, lack of agricultural inputs, and conditions to enable increases in agriculture yields. And the use of nondescript, uncharacterized genetics and compromised production conditions that include extreme climatic conditions, diseases, and low quality nutrition. Poor nutritional status of some of the genetic inputs, including in livestock, in smallholder production and food and mixed farming systems, also have an impact on improved livelihoods. Of course, the lack of appropriate storage and post-harvest handling systems for improved shelf life, nutritional quality, and market access, and an under-resourced and often ill-equipped research, innovation, and extension system. At the heart of it, these need to be dealt with, and we need to find a way in which we need to respond broadly. Trends in agriculture research indicate that new technologies and innovation advancements are a necessity for scientific solutions that drive competitiveness of agriculture and sustainability of food systems. This is important, particularly if we are to achieve the objectives of a demand-led breeding program, which is throughout the full value chains. These advancements enable improvements of crops, production systems, productivity, as well as closing the yield gap, as has been articulated by the previous speaker. Just to quote what IFPRI once said in one of its publications, to say there is extensive empirical evidence that demonstrates that agricultural research and development investments have greatly contributed to economic growth, agriculture development, and poverty reduction in many developing regions over the past 5 decades, effectively disseminated new technologies and crop varieties resulting from research and development investments have enhanced the quality and the quantity of agricultural produce, at the same time increasing sustainability, reducing consumer food prices, providing rural producers with access to markets, and improving gender-based allocations and accumulations of physical and human capital within households. Given the important challenges such as rapid population growth, adaptation to climate change, increasing weather variability, water scarcity, and the volatility of food prices, policymakers must recognize the value of greater investments in agricultural research and development as an essential element of increasing agricultural productivity. It is therefore appropriate to consider a few examples about the impact of agricultural research and development on food and nutrition security. You have heard I am from the Agricultural Research Council, and we do conduct probably one of the largest breeding programs in the country, particularly plant breeding programs. I will provide you some of the examples, but let me pull out an example such as the dry bean research breeding program, which we conduct not only in isolation as the Agricultural Research Council, but we also conduct with partners in the country as well as around the globe, including institutions such as CIAT and so on. Dry beans are the most consumed whole food legume globally, we all know that. Therefore, their increased production is essential to ensuring food security for many poor households in Africa and in Latin America. Dry beans are a great source of protein, complex carbohydrates, and soluble and insoluble dietary fibers, and they have no cholesterol. These are things we all know, all of which are important in sub-Saharan Africa, where micronutrient and protein deficiencies are prevalent. Dry beans, often called the meat of the poor, provide micronutrients to more than 300 million people in the tropics and in many areas, are the second most important source of calories following maize, according to the CGIAR. Given the large population growth rates in sub-Saharan Africa, increases in dry bean yields will need to at least equal or surpass that of population growth to ensure food and micronutrient security. Historically, South African farmers have used low-quality bean varieties, mainly from miscellaneous genetic resources. A study conducted by the Agricultural Research Council on the impact of investments in dry bean breeding program has found that in South Africa in 2010, dry bean accounted for about 80% of total caloric supply, which provided by pulses, and an estimated daily capita caloric supply of 25 kilocalories. Since the 1980s, dry bean yields in South Africa have increased from 984 kilograms per hectare in 1972, the initial year of the ARC, the Agricultural Research Council breeding program, to 1,200 kilograms per hectare in 2013. This yield increase equates to a 116% increase from 1972 to 2014. Or in simpler terms, a 3.7% increase per year. These findings indicate that the returns on investment are relatively high, estimated at 5.7 to 1 best benefit cost ratio, and they can lead to greater food security through increased stabilized bean yields. The growth in South Africa's dry bean production is partially attributed to past investments in dry bean research, specifically conducted by the Agricultural Research Dry Bean Breeding Program. We have published this particular study in the Journal of Agriculture and Applied Economics. If I were to give another example, not necessarily by the Agricultural Research Council around the implications or the impact of breeding programs, the example would be the summit wheat breeding program in Mexico. An analysis of productivity gains from summit release semi-dwarf bread wheat cultivars over time using test plot data from Mexico's Yaqui Valley. Previous studies have shown a deceleration in irrigated wheat yield growth since the 1980s, which could be due to slowing increase in genetic potential. The analysis in it suggests that the summit cultivars contributed about 0.46% annual increase, about 38 kilograms annually to wheat yields in the Yaqui Valley, which raised local wheat producers' revenue by an average of $4 million annually for the period 1990 to 2002, by approximately $9 million in 2002. These are significant increases in the livelihoods of the people in Mexico, but in the GDP of the country as well. If I were to then choose a cash crop, a high value crop, as also one of the programs that we run within our cultivar development or breeding programs in the ARC, the table grape cultivar development program. South Africa produces grapes that are either consumed fresh, dried as raisins, or processed into jam and jellies and wine. The table grape industry contributes towards employment creation, foreign currency earnings, and farm income generation. As such, it features among most labor-intensive industries in the country. Grapes comprise about 32% of total area allocated to deciduous fruits in the country. Research and development is among the factors contributing to the success of the table grape industry, and you'll understand why in a minute. Innovations facilitate and keep the table grape industry competitive enough to meet the needs of the consumers. This is what is important around focus throughout the whole value chain. In a study conducted by Mazwan et al., much more recently, to look at the impact of the investments in the breeding program on table grape, it sought to estimate the genetic gains and associated monetary value that is contributed by the table grape breeding program of the ARC, the Agricultural Research Council. These scientists used the just production function and cost benefits model to analyze the administrative program costs and industry yield data for the ARC's cultivars. The results revealed an average annual yield gain of 0.21 tons per hectare for the period from 1965 to 2014. A benefit cost ratio of 4.85. A modified internal rate of return of 18% was also revealed, suggesting that for every rand invested in the program, 4.85 rand is realized, confirming the value add of these particular investments. It further provides a demonstration of the positive impact of the investments into the Agricultural Research Council table grape breeding program, including the associated impacts that it has on the agriculture sector. Now, obviously, part and parcel of these particular investment and these particular breeding programs is not just for income, but it also is to enable the resilience of agriculture to climate change. If we are to look at a project that is a multidisciplinary program, that was done by a multidisciplinary team from a variety of different countries around the enabling resilience to drought. Considering that drought is one of the major abiotic stresses that limit maize yields in Southern Africa, a public-private partnership involving the national agricultural research organizations of at least 6 countries, Mozambique, Malawi, Kenya, Tanzania, Uganda, and South Africa, with CIMMYT, and a private multinational seed company, in this case it was Monsanto, was established under the auspices of the Water Efficient Maize for Africa, WEMA. The purpose of WEMA was to develop low-cost varieties of maize that are drought tolerant and assure increased maize yields for smallholder farmers in Southern Africa and Eastern Africa through the deployment of various technology transfer techniques, including agricultural research for development. On-farm demonstration plots resulted in considerable maize yield increases that are more than 25% among smallholder farmers, with several hybrid varieties released that subsequently were found to provide protection from the stalk borer and for armyworm. It is important to note that research and innovation is primarily focused on enabling agricultural resilience to climate change, mainly drought tolerance, through development of drought-tolerant cultivars such as maize, inserting nitrogen-fixing bacteria into plant cells and so on, reducing losses to insects, fungi, and weeds. It is estimated that plant breeding accounted for about 50% of the productivity growth in food production, while external inputs such as fertilizers, pesticides, and irrigation water contributed the rest. To meet future population demand, there's need to increase food production significantly by more than 60% in the future. The challenge is how can increased food production be achieved in declining availability of land, quality of water, other natural resources, biodiversity loss, and pollution, as well as climate change. Clearly, there's need for innovation and invention through introduction and the use of new technologies that increase food production with less land and fewer natural resources, in a future that can be addressed through further investments in plant breeding. In terms of the future of plant breeding for food and nutrition, what can we expect? There is need, therefore, to consider prospects for further improvements in yields and productivity, including where necessary nutrient improvement. Briefly, the horizon suggests further research and development could enable innovation for the introduction and use of the following key technologies: gene editing or targeted mutagenesis. Essentially, 3 main genomic editing tools that are currently being used are zinc finger nuclease endonucleases, transcription factor nucleases, like CRISP, TALENs, and CRISPR-Cas, and so on. These tools can be used to replace gene sequences, delete specific sequences, introduce mutations, including base substitutions and deletion or insert new genes. Genome editing interventions can therefore result in widely different genetic outcomes, including some that are indistinguishable from those that can occur naturally. Needlessly, but more importantly, examples of traits that have been developed already through gene editing, such as through this new technology of CRISPR-Cas, are the reduced phytate, waxy starch, and disease resistance in maize, powdery mildew resistance and low gluten in wheat, improved oil quality and delayed flowering in soybean, seedless fruit development and longer shelf life in tomato, high amylose, fragrance and yield components and improvements in rice, and many more. There are many more that are coming through since this particular technology has since been discovered. Others could include the use of genomic selection for quantitative traits. Alternatively, also genome-wide associated studies could also be used. A focus on molecular epigenetic events, synthetic breeding by genome design. But one of the key things that is coming through that is going to have a major impact in terms of how it shifts the way we do breeding, as well as the way we conduct our science, is around the focus on data science. Effectively inclusive use of evolutionary algorithms and machine learning for better prediction of lines and their crosses and enhancing the precision and efficiencies of crop improvement programs. This could also accelerate our breeding programs. It could reduce costs in our breeding program. Innovations and increased focus on science and technology for a knowledge-based economic system is vital for the success of agriculture to meet current and future demands. There is need to invest in human resource development as well, particularly multidisciplinary fields and skills to enable the development of skills that will enhance innovation and productivity. Accordingly, there is no doubt in my mind that we need to increase our investments in agricultural research and development, particularly agricultural research that is critical towards ensuring food and nutrition security for all. As a primary industry, we need to remember that agriculture has an economic multiplier effect with significant impact on job creation, improved livelihoods, and competitiveness of the various enterprises in the agriculture sector, sustainable growth, rural development, and social coherence and social stability. Let me stop there and thank the organizers for this particular webinar.
Thank you so much, Dr. Mapuli. You will probably have seen, if you have your chat group open, that there are some links to references there from the presentation. And just a reminder to make use of the chat for questions to be addressed in the discussion later. We'll move straight on to our next presentation from Dr. Ephraim Kudzashe Havasvidi. And he is a very experienced senior group research consultant, now retired. He worked with SEEDCO, which is, of course, a Pan-African organization, and he was leading the research and development in that group. He has focused on wheat breeding and seed production technology research, and he has done some plant breeding strategy under climate change conditions, and also represents Sub-Saharan Africa on a CIMMIT committee that has to do with wheat breeding. So he is going to share a little bit more with us about his experience and the opportunities and challenges of breeding for a market-led Pan-African region and the lessons that he's learned from his career. So I'll hand over to you.
Sally. Right. It is my pleasure actually to present at this forum here the demand-led breeding platform, and knowing that SEEDCO really has been on this particular trend since time immemorial, and I'll relate about SEEDCO trajectory from 1941 up to now. And out of that, obviously the issues which SEEDCO is written on will buttress or at least bolster the issues which have already been related by previous speakers. We have done it very well. Namely, that breeding is really demand-led. Who are you breeding for? And who is going to use the crops? That means the customers. So it's a holistic approach to do with the product which you are going to breed, that it's going to meet the expectations, the demands of the whole line of stakeholders. And that's exactly what SEEDCO, to a greater extent, has addressed during its breeding career in a variety sort of provision in business. I got to raise this one here. Sorry. How do I raise it?
You want to share?
Yes, I want to share now.
Okay. So you go share screen.
Share screen, yeah.
And then
show screen. It's on my own.
Yes, sir. Or can I share it from my end? I can do it from my side.
Yeah, please, because it seems to be.
Okay.
Yes, please.
I will.
Yeah, thanks. Right. That's the title of my presentation, opportunities and challenges of breeding for a market-led Pan-African region. Lessons learned from CITCO. And I will share on the regional presence of in the footprint of CITCO. Next, please. Yeah, this one here on the regional presence of CITCO on the major breeding stations. Where are we doing our work, and on where have we extended to in Africa, and the challenges we have faced, we have met with, and characteristics of the centers upon which we breed. How do they help us in our breeding sort of business? And then the appraisal of the breeding program. How have we been faring, and how are we faring now? Then I will share on what have we achieved in coming up with varieties. How have they answered the expectations of the whole range of stakeholders? And then conclusions and acknowledgement. Next, please. Right. CITCO, I wouldn't read through all this, but the issue about CITCO is it started off from a very humble beginning as an association of farmers who were entrusted by government of Rhodesia, then now Zimbabwe. They were, those group of small group of farmers were entrusted to grow and market seed, which of varieties which were bred by the government of the day. But it was on exclusive basis. They were running a monopoly up until very late, and I will discuss that later. Then from there, it changed from a maize producing and marketing organization to including all the whole range of crops, including the major ones, soybeans and wheat, and other crops as well. I'm talking about the oilseeds like groundnuts, and also the millets, sorghums, and the pearl millet. Then during the course of time, CITCO began now to develop. Next, please.
Oh, sorry.
Yeah. Yeah. Okay. Let me just show you the extent to which CITCO is grown in Africa, in sub-Saharan Africa. That's what you are seeing on the screen there. We have been everywhere, really, and we're talking about the tropical region of Africa, and more so, and also the subtropical as well. The equatorial is very important to note. So we really widely spread in sub-Saharan Africa. Then next, please. Yeah, that's the scope of what you are seeing there on the screen is the position of the major research station centers. But I will describe their characteristics or the properties of these particular research centers in terms of breeding, because that is very important. Next, please. Right. Now the history, I think it's important. I'll rush through this one, but from there you will capture exactly the issues to do with what has CITCO bred, how was it received by the stakeholders, and what opportunities did CITCO seize on that, and also what in this new era of breeding, what can be captured in terms of progression of the new breeder schools of breeders. I had mentioned that I had said that the Rhodesia Seed Maize Association, upon which CITCO was funded, produced. I think it's the slide area. Then I think go up. Slide up.
One.
Slide up, please.
Again or up?
Up, yeah.
The map.
Yeah. Yeah. Now, one slide down. One slide down, yeah. Right, okay, here. The Rhodesia Seed Maize Association, upon which SIDCO was founded, produced and marketed SR 52. I think most of readers know about SR 52 in 1960, being the first in the world to produce and market a single cross in maize. And then this SR 52 was so outstanding in performance in large commercial farmers that the smallholder farmers and adopted its culture, and it's important here in areas of Zimbabwe with long rainfall. The Zimbabwean government breeders then breeding for Zimbabwe Maize Seed Association immediately saw the need to breed maize hybrids suitable for rural and smallholder farmers occupying marginal areas of Zimbabwe. And from there on, the smallholder farmers actually began now to use hybrid seed, making actual Zimbabwe at that time in the world to have the greatest proportion of farmers using hybrid seed culture. Three-way early maturing hybrids, R200, 201, 215 by government breeders, and later 501 by SIDCO were released for smallholder adoption with outstanding boost in grain yield of maize in marginal area communities. Next, please. Then the appropriation of the organization, or the appropriation of seed packet sizing, and the reduced seed price of three-way hybrids further encouraged the adoption of high-performing hybrid culture in the smallholder agricultural sector, leveraging hybrid seed business of the organization. Amalgamation of this Zimbabwe Seed Maize Association and Crop Seeds Association in 1983 to become SIDCO, Seed Cooperative Company of Zimbabwe, widened the scope of seed business to include other crop seeds, namely soybeans, wheat, sorghums, millets, and groundnuts. Seed Company of Zimbabwe immediately saw the need to step up variety improvement in the seed production technology research at first of all, the Ratrano station, which is the hub even up to this day, which it had procured in 1972, and manned by a sole breeder, Alan Rattray, helped by Mike Caulfield. And then this Alan Rattray, together with Harry Arnold, are the ones who bred SR 52. We need to take note of that. The most experienced and competent breeders, namely Alan Rattray, Michael Caulfield, Rex Tattersfield, Ephraim Havashidi, Paul Rupende, Jacob Tichagwa, Rob Wolver, Barry McCarter, Jeffrey Hildebrand, and others were subsequently engaged. And then flotation of the SIDCO shares in the stock market to become SIDCO Group further encouraged local plus foreign investment towards plant breeding research, increased the seed production and market capabilities with the concomitant increase in regional seed distribution and marketing. So obviously the whole issue to do with the seed delivery, breeding, production, processing, marketing, those value chains were augmented by injecting heavy investment. Then very importantly, talented young breeders have been engaged. Namely John Derera, most of us know him, Hapson Mshoriwa, Goten Mambiai, Tebwe Sokoele, Tembe, Lenin Musontire, Caleb Sota, Tempa Mtuvira, Rotary Gunundu, Marvin Mshai, Lenmo Mazingeni. I mentioned these names because already in the breeding fraternity, you have met them, and you're rubbing shoulders with them, have been employed. And also in other countries, respective countries where we got research stations, namely Zambia and Kenya and Nigeria. That's what we got Hebert Masole there. We got Peter Mbogo and Joseph Mito. And then we got 4 ladies in the team who have been employed together with the other breeders, and a pathologist and the biotechnologist, Meluleki Sikali being the Dr. Meluleku Sikali being the biotechnologist, pathologist Nyasha Shuraise, they are still on the show, they are around with us. And then from there on, maize, soybean, and wheat seed product development and evaluation research has since grown into an African regional undertaking for SIDCO. Next, please. Next. Next, please.
Yeah.
Yeah, good. Okay. This slide, which is in front of us, I think to all of us, it becomes important. What challenges and we SIDCO has encountered and is still encountering, and what sort of mitigatory steps has the SIDCO taken to overcome them? We must understand that to breed for the whole of Africa, you are looking at a very problematic playing field, namely the agroecologies, which are very diverse, and now bearing on the breeders to come up for each of the market or the market segment a product which is which works for them and which does well for them. And because for Africa, we're talking about different topographies, we are talking about climatic differences from tropical weather to subtropical weather to equatorial weather, and then there are lowlands, very low-lying along the ocean, but also the highlands of the equator, and we are referring to Eastern Highlands here. So it's very diverse. Then we could also diverge in market demands vis-a-vis. For instance, in terms of maize, Malawians insist on flinty maize because they pound their maize, and also other related markets. But for South Africa, they require very fast dry down. So, you know, it's really opposing diversion systems, which you must really breed for and have the right germplasm for that. Then for soybean is very sensitive to the photo period. So naturally, Africa is wide as it is in terms of the photo periods, but in terms also of altitudes. You have to write to have the right genetic material, say for subtropical issues like South Africa, push-ups from there. You are looking for very early maturing when you're in Zimbabwe to get the material which suits South Africa. Meanwhile, for East Africa, you need very late maturing soybean varieties to cope for that environment. So those are the challenges which we meet. Then majority of farmers in Africa are resource poor, while intensive and large commercial farmers demand high crop uniformity and high yield potential. So naturally, when you breed again, you got to ensure that you got product which fits all those sort of market requirements. Then there are other pandemics which are current in Africa now, like the maize lethal necrosis disease in East Africa, which could spread into other regions as well. Then you got the UG99 in stem rust in wheat, is a yellow rust as well. Wheat blast, which is becoming important, economically important. Then the soybean rust, which also is coming up into the continent. The Russian wheat aphid deinoxia in South Africa, it hasn't spread much elsewhere, but at least it's something which could also affect other pockets. So these are the challenges which SIDCO has encountered. And now in terms of mitigation, with breeding success, there are 4 pillars which have been inferred, and I'm going to refer to them now as we talk. Vis-a-vis is the people which I have been relating, because I dwelled quite a lot on the breeder, constitution of the breeders, is the people, the availability of the genetic material. How do you get the genetic material? And it's important in terms of now, and then the facilities. Where are you breeding? Are you breeding in the environment which you are going to release in terms of the constraints which are made in those environments? And then the customers, how are the customers viewing your product in terms of the final utilities? So those are the pillars of success if we are going to come up with a demand-led product. Now, to do with mitigation, CIDCO in particular, has positioned itself in such a way that it amassed a lot of very rich, diverse germplasm. First of all, in the collection of locally adapted populations of the various different groups in the areas where it has been breeding, but also formulation of a very resourceful base of partners and collaborators who would also allow CIDCO to have exotic germplasm to help enrich the area. Right. Now, to do with the research stations, characters of the research stations, very important. You can see how, with that investment which CIDCO put in research, it established a number of research stations in the hotspot areas or the different agroecologies, so that the breeders can use those facilities to breed appropriately for the different constraints which are met in the different area zones. We got the Ratran research station, the exact location is given there, and you got also the biotic and abiotic stresses associated with the various research stations. So you see, we are quite well covered. Kadoma in particular there in Zimbabwe, very important research station for heat and drought stressed conditions. And the material which comes there has been very helpful to CIDCO in a lot to come up with varieties which are heat and drought stress tolerant for the region. But also from other research stations near the coast, low-lying areas. So that has helped a lot. Next, please. Yeah. This particular situation here, that's from Absalom Shoriwa, we are seeing here the breeders, the breeders equation. And where the duration you take to breed is really to do with how long do you do it for? Because you want to move the product faster. And then the accuracy, how are you doing it? To do with the phenotyping, genotyping platforms which you have in your breeding sort of exercise. And then the intensity. Intensity is really the selection pressure, because the more strictly you used to select in ours, the fewer material which you select is performing the top. It means that you gain also higher progress from that. And obviously, tools like genotyping tools are very important in ensuring that. Then genetic diversity, I mentioned that is really trying to collect as much as possible in how you handle the breeding methodologies which you use. Now, next, please. Next, please. Yeah, this is what we have done without laboring this particular position here. This is what CIDCO is done to do with the four components of the breeders equation vis-a-vis the duration. We got off-season breeding advanced necessary advanced sites where we speed up breeding by having 2 or more generations per year of breeding. And then we also have we have to do with accuracy. We got very good phenotyping tools to do with machinery, mechanization, but also measuring gadgets which we have on the station, which are listed there. the selection intensity is repeating the same really. We got quite a number of facilities for that. SIDCO has a number of facilities for that. Genetic data services, we got ICRISAT, we got CIMIT, we got ARC is our collaborator as well. We got NARS and National Agricultural Research Systems, which we line ourselves up with to share germplasm and get germplasm from. Next, please. Next. Right. So what have we come up with? What has SIDCO come up with? SIDCO is the first in the world to introduce a single cross in commercial production and the maize hybrid culture, and the maize hybrid culture in smallholder agricultural sector in Africa. That is very commendable for SIDCO to have done that. Then SIDCO is so far released the maize hybrids which are resistant to a number of diseases, namely to stricken motor virus resistance, very important, but also to heat and drought stress tolerant, which are heat and drought stress tolerant. Sorry if I may have maize again. Yeah. SIDCO, I will need to repeat, the SIDCO is the pioneer in the release of maize, streak, and motor virus resistant hybrids, but also to gray leaf spot. It was the first other organizations that come in, and the things are working for customers to have varieties which are resistant to streak and motor virus and the gray leaf spot, which are really devastating in Africa, a number of pockets in Africa. And also it has come up now in very ultra early heat and drought tolerant maize hybrids, which can fit very small short seasons. Next, please. Yeah, with the soybeans, it has done very well. SIDCO and come up with high performing soybean varieties, some of which now are resistant to soybean rust. And it's actually in the world rated top in coming up with a method of breeding, natural breeding for soybean rust. And then in wheat, SIDCO has come up with some high yielding irrigated spring wheat types, which is actually helped the country to be top in the world in terms of obtaining commercial wheat yields under irrigation of spring wheat. One of his varieties called Select is a white grain type, but very well balanced in the dough and also very strong, so it can be used for gristing with weaker types of flour. Next, please. Yeah, in conclusion, SIDCO has gained regional prominence in crop breeding through resolute investment in research and development. Regional presence of SIDCO research effort has enabled the organization to breed against biotic and abiotic stress eventualities exacerbated by climate change. Manning of SIDCO breeding programs with long experienced breeders along with qualified young breeding practitioners duly trained has ensured timely release of demand-led crop varieties across Africa. Most of the breeders of SIDCO are PhD, masters and PhD levels, more PhDs. Educated in University of Zimbabwe, University of South Africa, like KwaZulu-Natal, Orange Free State, and so on. Advanced mechanization of research operations and equipping breeders with advanced genotyping and phenotyping tools has speeded up genetic gains and thus variety resistance to the various market segments across Africa. Next, please. Next. Yeah. New diseases such as maize lethal necrosis and UG99 step rust and the wheat stripe rust and wheat blast require concerted breeding effort, and that is taking place right now within SITCO. High genotype by environment and genotype times environment times management. It has been raised by the previous speakers, how people manage their crops, very important. But as a breeder, you actually breed for those interactions as well. Interactions define and characterize market segments for which to breed for in Africa. Establishment of resourceful partners and collaboration networks are critical for successful implementation of research and development programs. There are thus numerous opportunities and scope to breed crops for Africa. Next, please. Acknowledgement. I'm pleased to acknowledge a demand-led platform supported by University of KwaZulu-Natal, African Center for Crop Improvement. I appreciate for organizing this webinar, one in plant variety design for emerging markets in Africa. I am also thankful to SITCO Group Limited for availing the corporate information cited in this presentation. Dr. Hapson Mshoriwa now is ICRISA provided the breeders equation models, while Mr. Davidson Mkwene Tapiwa Marume typed the presentation slides. Thanks. Thank you.
All right. Thank you so much,
Thank
Christine.
you so much for that presentation. I see that there is a question in the chat box, so I'll just direct your attention to that. We are running a bit over time, but we'll do our best to wrap up by 12 for those who have other engagements to get to. Our next and final presentation from a keynote speaker is from Mr. David Cochrane, who is a partner at Spoor & Fisher in South Africa, and he is a patent attorney with more than 2 decades of experience in international and domestic patent matters. So that includes a number of fields: pharmaceutical, nuclear medicine, petrochemical, agrochemical, explosives, biochemical, a lot more. So it's going to be very interesting to hear from you, David, about the patents, trademarks, and copyrights that affect plant breeders. So I'll hand over to you to take it from here.
Good morning, everyone. Thanks for the opportunity for taking part in this, and thank you to the previous speakers for very interesting presentations. I'm going to try and share my screen. Okay. That's not the right one. Okay. Sorry, what is coming up on the screen now?
It's the cover, the first slide.
Ah, fantastic. Okay, great. So I'll be giving a brief presentation on IP protection for plant varieties. Dr. Yao mentioned how much goes into investment in breeding new varieties, and he also mentioned about getting a return on investment. One of the ways in optimizing return on investment is getting exclusive rights to the variety, those rights that you can either use yourself or you can license. And obviously through that getting exclusive rights, you're able to get more of a return on the investment that you've made in developing those varieties. Just from an international point of view, the main international arrangements relating to plant breeders' right to plant varieties are the TRIPS agreement and UPOV. Article 27 of the TRIPS agreement says that countries must provide patent protection, and there are various exclusions. One of the exclusions in Article 27.3 is that plants and animals other than microorganisms, and also essentially biological processes for the production of plants or animals other than microbiological processes, may be excluded from patent protection. So most countries in the world make use of this exclusion. So in most countries in the world, it's not possible to get patent protection for plants which are made by normal breeding techniques. And there's also, you can't get protection for normal breeding techniques. This doesn't cover genetically engineered plants. So genetically engineered plants are regarded as being made by a microbiological process. So in his presentation, Dr. Mpuli mentioned making new plants using gene editing. So new plants made by gene editing can be protected by patents. In the case where countries, as most countries do, not provide protection for normally bred plants, the TRIPS agreement says that the country must provide some other kind of protection, some sui generis form of protection. And the sui generis form of protection is in the form of plant breeders' rights, or also referred to as plant variety protection. And there's an international treaty called the UPOV agreement, which a lot of countries are part of, and which provides a framework for providing protection for plants which are produced by normal breeding techniques, and you can also obtain protection for plants which are genetically engineered plants via the UPOV system. So going on to plant variety protection, as I mentioned, the two main ways of getting protection is by way of patents and plant breeders' rights. Patents, that's usually limited to genetically modified plants and not plants produced by normal breeding techniques. There are a couple of countries which do provide protection, patent protection for normally bred plants, and one of those countries is the USA, but most other countries don't. Plant breeders' rights protect plants produced by normal breeding techniques as well as genetically modified plants. And in order to get protection for a plant by way of plant breeders' rights, the main requirements are that that plant must be new, distinct, uniform, and stable. The novelty requirement is that the person who bred the plant, the time limits by which you have to apply for protection after you've first sold the plant or made it commercially available. So in the country where it's first been sold, you usually have to you have to apply for your plant breeders' rights within 1 year of your first commercial use, or if the first commercial use has been in another UPOV convention country, it's within 6 years of the commercial use for trees and vines, and for 4 years for other plants. So I think the important thing for plant breeders to remember is that if you are looking to get plant breeders' right protection and also patent protection for a variety that you've been working on, there are deadlines, and you must make sure that that you file your patent application or plant breeders' rights application within the deadlines that are provided for. The other requirements are that the plant must be distinct, uniform, and stable. Distinct means that it must be different to other plants which are common knowledge anywhere throughout the world. And then uniform and stable means that it must remain uniform and stable after repeated propagation of the variety, well, of the plant. The duration of a plant breeders' rights, again, because most countries follow the UPOV framework, and the duration in most countries is the same. And that's 25 years in the case of vines and trees, and 20 years for all other varieties. The important thing to note is that usually that is calculated from the date of grant. That's quite important because it often takes quite a long time from the application for plant breeders' right to being granted, because the plants need to be examined by an examining authority, and it can take a long time, and a number of they might want to check a number of generations that they do comply with the requirements. So even though it might take some time for plant breeders' right to proceed, application to proceed to grant, the fortunate thing is that the duration is from the date of, usually from the date of grant and not the date of application. Protection granted by a plant breeders' right is quite broad. It's the production or reproduction of the plant material, conditioning for the purposes of propagation, sale or any other form of marketing, exporting, importing, and stocking. So the breadth of protection by way of plant breeders' rights is quite broad. Another important form of protection for plant varieties is trademark protection. Now, when a variety, when you file a plant breeders' rights, you have to give the variety a denomination, or even when you don't file a plant breeders' right, the variety is always given a name or the varietal name. And it's important to note that the varietal name is the generic name for that plant, and you can't get rights over the varietal name or the generic name. The way in which to get rights for the name of a plant is by using a trademark, and a trademark works differently to a variety name. A trademark distinguishes the goods or services of one producer from another. And in terms of the plant breeders' rights laws and also the trademarks laws, the denomination or the varietal name of a variety must be different to the trademark which is used for the variety. And the benefit for many times a plant breeder might only give a plant a varietal name or a denomination, and if you file a plant breeder's rights for that, and when the plant breeder's right expires, for example, anybody is allowed to sell the variety using that denomination or the varietal name, because it's a generic name. But if that plant has commercial value, it's a good idea to also use a trademark in conjunction, which is different to the varietal name, which means that once your plant breeder's right comes to an end, although anybody else can use the varietal name, you would be the only person who's allowed to continue using the trademark. And a good example of that is the Pink Lady apple variety. So the varietal name or the denomination for that apple variety is Crisp Pink. So when the plant breeder's right was filed, which is now expired, the denomination or varietal name used is Crisp Pink, but the owners of that variety sold it using the trademark Pink Lady. So even though the plant breeder's right has now expired and anybody can sell the variety Crisp Pink, nobody else can use the trademark Pink Lady. And there's still a lot of value in that, because Pink Lady is the name that the public is aware of. It's got a good reputation, and so even though the public Crisp Pink might be available generally to the public, they might and would very often choose to buy the Pink Lady apple, just because it's more well known. Copyright protection is mentioned in the title to my presentation. Copyright protection protects a number of works: literary works, artistic works, musical works, sound recordings, published editions, computer programs, but not plants. So plants are not protected by copyright. So really, when it comes to IP protection for plants, the main forms of protection that you're looking at are patents where it's available, plant breeders' rights, and trademarks for protecting new varieties of plants. Because we're in Africa and many of our colleagues attending this presentation are from Africa, I thought what I would do is just give a brief overview of plant breeders' rights in Africa. Now, obviously, plant breeders' rights are available in many countries throughout the world. So if a new variety has been developed in an African country, you can, within certain time limits, you can apply for plant breeders' rights protection in other countries in the world. But these are just the African countries where plant breeders' rights are available. So if you look at that map, we can get plant breeders' rights in Egypt. You can apply for plant breeders' rights in Egypt, Ethiopia, Kenya, Morocco, Rwanda, South Africa, Tanzania, and Zanzibar, Tunisia, Zambia, Zimbabwe, and OAPI. OAPI is quite an interesting system. all of the countries that you can see which have got little red stars next to them are part of a regional protection system called the RP protection system. It's mainly the West African and French-speaking countries. And in those countries, you can get plant breeders' rights protection by filing one application, and it automatically covers all of those countries. You can't choose the countries, you get protection automatically. In all of the other countries that I've mentioned, that are shown in black on the slide, you have to apply in those countries individually, and you usually apply. It's usually handled through the Department of Agriculture of the various countries. Ethiopia is an interesting country because a new law has been published but hasn't been promulgated yet, and there haven't been regulations. So the Ethiopian authorities, the Ethiopian Department of Agriculture, accepts plant breeders' rights applications, but they're not being processed yet until the new law has been formally promulgated. And there's been a recent development in Ghana. In Ghana, a new plant variety protection bill was published in 2020, but it's not yet implemented. Just very briefly, you may have heard of the static protocol for the protection of plant breeders' rights, and also the Arusha protocol for the protection of plant breeders' rights. So if you look at my slide, the top map of Africa in gray, those are your SADC countries, and the map below that in red are your ARIPO countries. Now, ARIPO, which is a regional system where you can get protection for patents, trademarks, and designs, and it works very well for those forms of protection. The head office of ARIPO is in Zimbabwe. ARIPO is looking at providing a regional system so that for plant breeders' rights, that you only have to apply at the central ARIPO office to get protection in all of their member countries. But to date, only two of the ARIPO countries have signed up, and another two are required. So that hasn't come into effect yet. And SADC is also providing, looking at a regional system, but only, and for that to come into effect, you require 10 countries, and thus far only 9 countries have acceded to that. So these two possible regional systems would provide good ways in which to get protection over a number of countries by only applying for protection in one place. But I think one of the difficulties here is that neither of them have come into effect yet, and when they do come into effect, it's going to be unclear as to which one people are going to use, because there's an overlap in the country. So the SADC and ARIPO protocols are interesting, but they're not in effect yet, and when they do come into effect, it's going to be interesting to see which one does and which one's going to be more successful. And then just to give you an indication of how long it takes to get plant breeders' rights in the different countries where it is possible to apply. One of the big things is that in order to get a right granted, the variety has to be tested. It has to undergo the DUS testing somewhere. And a lot of the countries, Egypt, Kenya, Morocco, RP, Tanzania, Zambia, Zanzibar, will accept test results which have been conducted by another country, which makes it easier to get protection in those countries. Zimbabwe doesn't require test results. In South Africa, it's quite difficult, particularly for foreign country, for foreign or companies from outside of South Africa to get protection, because they might have had test results conducted in their country, but South Africa won't rely on those test results, and you have to import the material into South Africa and undergo the examination. So in South Africa, it can take quite a long time. So protection in Egypt can be quite quick, 6 to 9 months. Kenya, 4 to 5 years from application to protection. Morocco, about 4 years. RP, 2 to 4 years. South Africa, 2 years and upwards. Tanzania, 6 months. Tunisia, 5 years. Zambia, 6 to 12 months. Zanzibar, 6 months. And Zimbabwe, 1 to 2 years. So the amount of time it takes to get protection differs from country to country. But as I mentioned earlier, your protection usually runs from the date of grant and not from the dates of application. And yeah, thank you very much. That's just a very brief overview of IP rights for plants and situation of plant breeders' rights in Africa.
Thanks so much, David. That was so interesting. I know that that would be very useful information, and there is some discussion in the chat about what you've been sharing. So we are due to end this meeting in less than 5 minutes. However, I know that there have been a couple of questions. So if you are happy just for me to pose 2 questions that have popped up in the chat to 2 of our speakers, I will do that and then hand over for closing remarks. A reminder that you can pose questions in the chat still now while we wrap up, and if we don't get to it, we can ask the speaker to address it directly via email, or we will contact you between the 2 of them. So one of the first questions was for Dr. Habazvidi, and the question was, which seedco wheat varieties would you advise for testing in the Sahel during the cold dry season, so November to February, where temperatures are between 16 and 28 degrees Celsius under irrigation conditions? I don't know if you'd like to address that, Dr. Habazvidi.
David, may I ask, I think you are still sharing the screen.
Okay. Hello. Yeah. Which part of Africa is this one? Which part of Africa?
It's in the Sahel.
Sahel.
Yes.
Where is that? Sorry.
So that question is from Muniru. I think that I'm saying that correctly. So perhaps you could just give us some clarity. West Africa.
I would suggest that they would try SC Nduna and the SC Select.
Great, thank you. Short and sweet. I hope you received that answer. And then a question for David about distinguishing between, or giving the difference between trademark laws and plant breeding laws.
Okay, sorry. What was the question there?
The question was to distinguish the difference between trademark laws and plant breeding laws.
Yeah. Okay. So trademark laws. That's a name that you give to your variety. So the example is the apple variety is Pink Lady. That's the name that you give it. Plant breeding laws and plant breeders' rights protect the actual variety itself, the plant itself.
I see Charles has given a little bit more context to that question, saying it's about enforcement of protection mechanisms under the different protocols, so including plant breeding in terms of existing legal systems or courts of law in different countries.
Yeah, so most countries have got trademark laws. If you've got a trademark for your variety, you'll be able to enforce your rights in most countries. Whereas not all countries have got plant breeders' rights, and you have to apply for plant breeders' rights in the country that provides for it. So you need to get it registered, and then you can only protect in countries that actually do provide protection for plant breeders' rights.
Great, thank you. I don't see any other questions coming up in the chat. There is one's just come up also for David about the time period for copyright. I don't know if that's in terms of application or in terms of how long the copyright applies.
Yeah, so as I mentioned, copyright protection is not available for plant varieties. So yeah, there is no protection by way of copyright. It's only patents, plant breeders' rights, and trademarks. Those are the three forms of protection you could look at.
And another question about the drastic differences in the length of time for obtaining plant breeding rights, whether this has to do more with how rigorous the trial process is in some countries as compared to other countries, or if there's another reason that makes that a long process.
Yeah, so it's to do with if the plants need to be examined, go through a whole examination procedure. That's one of the main things. And then some countries which don't, which rely on results from other countries, the length of time that would just be because of administrative procedures, I guess. Yeah, administrative procedures, and in some cases delays.
Perfect. Thank you. I think that answers those questions. There aren't any more coming up, but a reminder that you can get in contact with us if you have a burning question. And I know some of the speakers' details were in their presentations if you'd like to contact them directly. And so it is now 12:01. So I'm going to ask Mr. Jean-Claude Rubiogo from the Pabra Bean Program in Kenya to give us some closing remarks, and then I'll just wrap up after that with some reminders. Thank you.
Okay, thank you, Christine. Are you able to get me?
Yes, we can hear and see you.
All right, yes. I just wanted to thank the organizers, Shemelis, who has taken really his effort to make this happen, and also your university and others as well. I also want to thank the presenters, very relevant and very excellent presentations. Also to thank the participants, above 100 for their time, more than 2 hours. That shows that the DLB is a very interesting topic and very relevant to the breeders and many other people who have a stake in the DLB approaches. That's really very interesting. So again, it's on behalf of the Pan-African Bean Research Alliance, and I'm also the director of the Global Bean Program within the Alliance of Biodiversity International and CIAT. We're pleased to see the story from Shadrach on the beans in South Africa. That's it's a part of the Pan-African Bean Research. Really want to see this. It's because of the demand-led breeding they're able to make this progress, increase their productivity, satisfy the needs of the people who need it. So it's again very amazing to see the interest of the DLB, the participants, the practice, the kind of practice has really improved. When we started to where we are, it has expanded. That shows really that it's a topic which is very relevant, not only to the breeders and other, including even the lawyers. That's something very, very, so it's good to keep on pushing this boundary of plant breeding beyond the normal practice, but be innovative and get really the industry flourish and benefit millions of people. So as a host of the DLB, we're really privileged, and we wanted to really to see this experience going to other crops. We have started that in beans for some time, what we used to call market-led breeding in 2000, and we have seen this doubling the yield in many countries, as South Africa was an example. Ethiopia, we doubled the yield from 0.6 to 110.7. Uganda doubled the yield from 0.8 to 1.7 now, ton per hectare. Burundi, even small country like Burundi, again doubling their yield because of really engaging the users from the beginning to the end. So that helps to adopt the variety. That's helped to commercialize the variety because that's what farmers are looking for. So we really see the possibility of expanding this to other crops as well, and make sure that this really translated to many other benefits, breeding beyond just breeding for having the variety, but breeding for job creation, breeding for economic opportunity, inclusive for health and nutrition. So all this really shows that there is a possibility that we can sell the work of breeders beyond just breeding, but to all these multiple benefits. And I think really Richard talked about it. Sometimes that's an area we need to push more interest. There's a lot of conflict on interest, on various interests coming together. So unless we really have a good case like what we saw today, people presenting, otherwise the policymakers will not be able to listen. So as we close this, I think probably the next steps we should be thinking is that how do we sustain the breeding? How do we get the funding to the national programs? How do we get the funding to the private sector? Somehow they are funded, private sector is funded, but the national program very key because of some crops which are not in the private sector hands. So how do we, that question remains, and I think we need to have some time again in the future, looking on how do we invest, how the public invests in these national programs, and the public investment would be very important. So otherwise, I really appreciate everybody's contribution and we wish you enjoy the rest of the day, stay safe and healthy. Looking forward for more discussions on this topic across not only East and Southern Africa, but also across other parts of the world as well. Thank you very much.
Thank you so much, Jean-Claude. We will be closing now. I just wanted to say we, because we've gone over time, we haven't been able to launch the poll that we would have liked some feedback on. So we will be in touch with everyone by email. So if you would not mind answering a couple of yes or no questions for us, that would be wonderful and very helpful. And if you have any feedback you'd like to send us directly, we would welcome that. And we will be in touch with you after this meeting about where you can access any presentations that are available and the recordings that are available. And we will also inform you about any recognition of attendance that you're able to get from this meeting. So, and if you have any further questions, please also do send them through. And Prof. Shimlis might have some final remarks.
Just from me also, Christine, thank you very much for handling this. This was really very fruitful deliberation, conversation. Thank you so much for the keynote speakers. I should appreciate you again, and it was really valuable. We learned quite a lot from this engagement, honestly. So it was significant, and we carefully chose also the subject areas, and by itself it shows quite extensive inputs and thought from you. So hopefully I think we have really taken quite extensive lessons and evidence from what you have presented to us, really from Richard, which was which involved quite a number of projects in Southern Africa. So what's really important for policy, what matters, what affects policy. And Dr. Shadrach, really, you gave us very valuable insights in terms of agriculture research and development in South Africa or Southern Africa at large. And you highlighted very key issues, the impacts of plant breeding. And there are quite a number of figures, data that shows that plant breeding is worth in investing. There are quite a number of returns on investment in plant breeding, be it in cereal crops or perennial crops. So it was excellent lesson from you, and thank you for those guidelines. Then Dr. Ephraim, the humble beginnings of Seedco to a commercial and successful Pan-African breeding, which is really remarkable. And you know, whenever we travel to East Africa or West Africa and Central Africa, we hear about Seedco, good news about Seedco, and its impact is clearly visible. And thank you for sharing how you do it. And I believe this is also a lesson for the young breeders to become investors, to become in the business of plant breeding. It was so educational. David, I think you gave us very good thoughts, ideas, and what's influencing our variety release and commercialization in Southern Africa or Africa at large. These are quite interesting. So moving forward, I will also try to make an announcement that we have chosen also other interesting topics in plant breeding, which affects the agriculture research and development community and plant breeders. We will communicate that, and after just few weeks time. So I really invite you to join us and also participate in these things. You know, these are things that we can't get through lectures or classrooms. So it was a wonderful experience for me. Thank you again for the keynote speakers and participants. We know that time was short to ask questions and to discussions, but it was worth listening the presentations, I believe. So I thank you again for everyone in Africa or in Europe and elsewhere who joined the webinar. If you have any feedback or questions, please email us to me, to Sally or Christine, and we are gladly happy to assist you or to converse with you further and to engage with you. Thank you very much. Christine, back to you.
Thank you, Shimilis. And of course, we will be in touch about further events that take place. And we would also encourage you to share those with your networks if you know of people who have not attended these webinars who would be interested. So from us, that's all. So thank you so much for your patience and for your time. And it really was a very insightful presentation, and any feedback is welcome. Thank you, everybody. Goodbye.
Can you have a photo, a screen photo? Can you show
Thank
us on
you.
your faces? Hello, hello, everyone. Can we see you? Yes. Christine, can you do screen, print screen? I think you are muted. Okay, Christine?
Yes.
Yes.
Everyone
I
ready?
think-
Okay, I'm going to do a screenshot right now.
Let's do
Here we
page by
go.
page. Then the next. The next. Yes.
Thank you.
Okay. Can you do the next one?